So let's go ahead and look at some examples here. So I'm going to do those first examples right there at the top with you guys. So the first one is 5x plus 2 equals negative 3x minus 12. So again, it does not matter which side you move the variable to. I think to keep things consistent throughout really the entire course of Algebra 2, I usually always move the variable to the left, but it really doesn't matter. But what you do have to remember is what you do to one side, you have to do to the other. So if I do want to move my 3x from that right-hand side, it's a negative, so I add it. You just have to make sure you do it to the left-hand side. So just remember, you do it with the like terms. We're not going to do 2 plus 3x because they're not both x's. If we're adding an x, we need to add it to another x term. So 8x plus 2. This is now gone, equals negative 12. So now I will move the 2 over. 8x equals negative 14. And then it's 8 times x, so we will divide by 8. For the most part, in this course, I will keep my answers as fractions, but as always, there's nothing wrong with writing them as a decimal. It's just that if you don't have a calculator, there's nothing wrong with saying x equals negative 14/8, or if you guys simplify it, negative 7/4. As a decimal, maybe negative 1.75. I'll usually leave them as fractions. So number 2, 5 plus 2 times the quantity, 3 plus 2x, equals 19. So I'm going to do two things at once. First, I'm going to distribute my 2 in there, and I'm also going to subtract the 5. So I'm going to subtract the 5. The right will now be 14, and the left will be 6 plus 4x. So since the x is already over there on the left, I'm just going to subtract the 6. And we get 4x equals 8. Divided by 4, and this one does give you guys a whole number. So that's the other thing. Don't panic if you get an answer that's not a whole number. Not everything in the world works out perfectly all the time. It's okay. And also, guys, this is algebra. So if you get an answer that's a decimal, plug it back in to your original equation. If it's the right answer, it should make your equation true. You can always check your work. So let's look at the fraction then. So this is your fraction, so that's the part you need to get by itself. So if that's the case, we need to remove the 1 from that left-hand side first by adding it. So now the right-hand side will be 8. So it's x plus 3 divided by 5. So it's over 5, but that means division. This is really just dividing by 5. So what's the opposite of dividing by 5? Multiplying by 5. I'm going to do it over 1 just to give us good practice here. So 5 on the top, 5 on the bottom cancel, divide by 5, multiply by 5, undo each other. So really what you guys would have on this left-hand side is x plus 3 over 1, but we don't put things over 1. So you're left with just x plus 3 equals 8 times 5, which is 40. Subtract the 3. X is equal to 37. I'm not going to do too many examples with you guys because this is review, but I just want to show you that fractions are not that bad. So I'm going to do 2 more fractions with you and then have you guys do the rest. So I'm going to go to this next page here and we'll try the 2 I have highlighted there. So here, 3/7 x plus 9 equals 15. Same thing, guys. That fraction needs to be by itself. So we need to get rid of the 9. So 3/7 x now equals 15 minus 9, 6. So this is 3/7 x. So this is really 3 divided by 7 times x. So even whether the fraction is in front of the variable, whether the variable is inside the fraction, you're still looking at whatever that denominator is, because whatever the fraction is being divided by, that's what we're going to multiply it by. So that is gone, and we're just left with 3 times x, which is 3x. You don't see the multiplication sign there, but that's all it is. So the 7's gone, 3 times x is 3x. 6 times 7, 42. Divide both sides by 3. So x equals 14. So let's go down here and look at the problem that's got 2 fractions in it. We didn't really specifically talk about one of these, which is why I'm going to do it with you guys. So because we have 2 fractions, it's kind of like, okay, well, what do we get by itself? Well, here's what I'm going to do. Since this has a fraction plus a number, or minus, but it has 2 things on this right-hand side, I'm going to move this 5/6 to the other side. So since it's minus, I'm going to add, and that is now gone. We're left with just 8. So when you guys add fractions, we still have sixths, like we're still working with sixths. But what is 7 plus 5? 12. So 12 over 6 really just leaves you guys with 2x equals 8. If you guys divide, x will be 4. So don't be afraid of the fractions. Just remember, what you do to one side, you must do to the other side. You have to keep it balanced and equal. And remember, if you don't get a whole number, you can plug it back in to check your work.